Welcome back to another Coding Cleverly video. Today we're going to be talking about doubly linked lists. This is an extension to the singly linked list. The doubly linked lists are just made up of nodes that have linkages to the nodes before and after them. Now we have 3 nodes. It forms a linked list, right? So in a doubly linked list, we have a pointer which points to the head, and this is called the head pointer. We also have a tail pointer which points to the tail node, and we also have this next pointer which points to the next one. But in addition to that, we have a previous pointer which points to the one before it. So it's like this, it's bidirectional. Before coding the doubly linked list, I want to give a real world example of where this is implemented. Your browser history is an example of a doubly linked list. So when you open up your browser, the page that you land on is the head of your list, okay? As you click on things and navigate to new pages, you are moving forward and adding to the tail of your list. If you ever want to go back to something you've already visited, you can use the back button to move backward through our list. So that's our example. And now let's start coding. Public class, I'm going to say doubly linked list. And inside of this, we're going to have to create some members. So remember we had a node.java file. This is our node.java file that we created for our singly linked list class, and we also did it for our node class. We are basically using this again and again. So if you didn't watch my singly linked list video, there's a card on the top right corner. You could click on it and check the video. Or if you didn't watch the node, so you could go and check that video out. It's in the playlist. Over here we have a public class node, and we have public string data, and we have private node next. Now, in addition to the next node, we have another node where we're going to be using, and that's going to be called as the previous node. So we're going to just add in that over here. Over here, we had a constructor which was public node string data. We had this dot data is data, and this dot next is null. And for this, we'd have the previous node as well. So the previous pointer would be set to null over here. Now we have set next node, and over here you can see that there is this dot get next node. So this dot next is equal to node, and you could be guessing that we'd actually need set previous node as well over here. So I'm just gonna have the duplication here, and over here I'm just gonna say set previous node. So I'm gonna replace that with prev, and once we're done with that, we just have the prev node, which is over here, and we just put the node here, get next node, and duplicate it here. And now we're gonna say public node get previous node. So get previous node, and we're just gonna have the previous node returned here. So this dot prev. Okay, we're done with this, and then we have this method. It doesn't really matter here, so we can just leave it as empty. This is just the implementation that we've done in our earlier examples, but just gonna leave it as empty right here, and it would still work. So now let's jump back to our doubly linked list.java file. So the first one, which is going to be called the public node head pointer. So remember, we already did this before in our singly linked list. But in addition to this, we have not only the head, but also the tail. So we can say public node tail. Now we're done with this, and we could go straight to the constructor. So we can say public doubly linked list, which is here, and just put this, and it's set them to this dot head, and we could set that to null, and we can say this dot tail, and that's set to null as well. Okay, cool. So we're done with this public void addToHead, and we want to, the string conventional, we want that string inside. So string data right here. And then we can just have the data passed in, but we have to create an instance first. Node, new node, and we pass in the data here. And then we just put a semicolon. We're done with that. We're accessing the node from here. And now what we want to do is we want to create a current node as well. So current node, and we want to set that to the existing head right now. So this dot head, doesn't matter if it's null or not, we just want it set to the head. Now we want to replace it, right? So we're going to have to put a condition first. First, we're going to check if the current node is not null. So current node not null, Okay, if it's not null. So since we had the current node dot set previous node, and the current node is originally the old head, and we want to replace it with our new head, right? New node. So what we could do here is we could have the set previous node set to new node. Once we do that, we actually set our previous node to our new node, which means that now if we talk about the new node and we say dot set next node, we're just gonna set that to the current node. So this is just settled for once and for all. And if we look at the other thing that we have, the this.head, I will set it to our new node, so right there, like this. In case of the tail, so we say this.tail is equal to null, we'll have to make the head, which is this.tail, is equal to the head what we just added. So we could just say the new node, which is working as our head. So this is our implementation for our addToHead method. If we just copy this exact same thing and just paste it down, we could create our addToTail with just a few changes. So the first change is the name of the method. Over here we're going to have to change it to addToTail. The data is okay. It's going to be called new tail instead of new node. We could call it as new tail. And the current node, which should be the current tail, right? I actually want to change my variable name, new node and current node, for my addToHead method, because I just want to keep it simple. Here we want to change the new node to new head. So I'm just going to select it, hold Alt key on my keyboard, and wherever a new node is existing, I'm just going to double click on it. So new node, new node, new node, and then we have new node over here as well, and we have new node over here. So you can see that there are now so many cursors here, and we could just like replace the new node to new head. So we can say head here, awesome. And now the current node should be replaced to, so I'm just gonna have to escape, and now I'm gonna click on this, Alt, and I'm gonna try to find my current node, which is over here. My current node's here, my current node's here, and that's it. So we're gonna node to just current head, like that. Awesome. Over here we're just gonna replace the variable names. So okay, over here you can see new tail, and this is the current tail instead of a current node. So we're just gonna replace that with current tail. And now over here in the if current tail, right, if the current tail not equal to null, so in this case we would have to set the current tail the current tail's next node. So it's like almost a mirror to the first method, but it's just a little difference. It'll replace it with new tail over here, and then the new tail dot set previous node should be the current tail, which makes sense. And now over here with the this dot tail, we just have it set to the new tail, right? Easy enough. And now what we're gonna do, the last case, is that if the head, not the tail this time, but the head, and we're saying if the head is equal to null, that means the head over here, so this dot head is equal to the new tail. The 2 pointers are just gonna point to one node. After this, we're gonna create the method to remove head. Public, we're gonna have a string here because we wanna try to get the data of the head. So we're gonna say remove head, the existing head. So to get that, we're just gonna have the body here, and what we're gonna do is we're gonna say node removed head, and we're gonna assign that as the current head, which is right here. Once we're done with this, we could actually have the method or the condition if the removed head what we got, in case if it was null, then we just have to return null. We want to get the removed head, we have to change our existing head to something after the removed head. So we can say removed head dot get next node. So that would just give us the next node, and that would assign it to the head. If the this dot head not equal to null, then we're good to go, and we can say we could say this dot set previous node, because we have to take care of the prev node as well, and we just set that as null because the head is the first node, so there's not going to be anything before it. And in cases if the removed head, which was what you did, is the tail, right? If it was the tail, meaning that there was just one node there, then we'd have to remove the tail using this dot removeTail. And this is a method we're going to be calling after creating our removeTail. So this is going to be a method. It doesn't exist right now, but we're going to call this to remove the tail portion. So it's just going to contain something empty. And then once we're done with that, we could just return the removed head dot data. There you go. So let's create our removed remove head, and now we're gonna create our remove tail. Just gonna replace a few things. So remove tail here, and over here we're gonna say remove tail. So we could do the same thing. So select all of it, press Alt on the keyboard, and just keep finding remove tail. So found it here, we found it here, and we found it removed head over here, and we just so we could select it, like we could just go there, and wherever we see removed head, we could replace it with removed tail. Okay, so we have removed tail. Okay, I made a mistake here, so I'm just gonna press this D, and this, the errors should be gone. Okay, so the removed tail, not remove tail, but remove tail. Over here we had removed head, and it was okay. So set prev node. Why is this giving error? The method set prev node null is undefined for the type doubly linked list. Actually, we need to get the head of the existing thing, and we have to set prev node of that. So like this, and that's why this is a null. Okay, now we have to remove tail. So this is the remove tail method. Okay, so over here we're gonna have to call it remove tail, not remove. Okay, and then over here we're gonna have to replace this to D, and oh yeah, that D's over there. I don't know why, but I just made a problem there. Okay, so first of all, we got the node removeTail, and we put it as the tail, which is the existing tail, right? Just the same thing what we did process there. If removeTail is equal to null, we just return null. Cool. If this dot tail, now we're gonna have to set the original tail to the removeTail dot get previous node, because we just removed this existing one. So we just need the previous node, or previous node, like that. Okay, so now once we do that, we could say if this dot tail not equal to null. So if it's not null, we could say this dot tail dot. So because we need the tail over there, we could say dot set next node, and we could just assign it to null, like this. Now, there you go. Remove tail is equal to this dot head. So over here should be head instead of. So remove this, and I say if the removed tail, what you just removed on the top, is equal to the head, then we could just remove the, call the removed head method, which would remove the head from this. So we would just call the removed head method, which is over here, and it just has to be the D over here. There's no D, so remove head, and this will call it and remove the head for us, and then it would just empty out the list, right? So once we do that, we could just get the removed tail.data. So the last method is removeByData. So public node removeByData, and we pass in a string data here. Now what we're gonna check is that if first we're gonna say node to remove, and we're just gonna assign that as null. Now we're gonna get the current node, and you're gonna be asking, well, we could just get it from the head, right? One way to process this, traversing the list, and it says if the current node, right, dot data is equal to the data that we passed inside of our input parameters, then we could just assign that node to remove current node, and we could break it. So that's it. Current node is equal to current node dot get next node. There you go. So this is how we're gonna traverse it out. Node to remove, was null. We have to set this condition out. So if it was null, we're just gonna have to return null, meaning that we couldn't find it. And if the node to remove was equal to the head of our list, right? So we already have the method which could take care of that. We could just call that method here. So we could say this dot removeHead. So we could just pass this and we're done with that. To remove was equal to our tail, not the head but the tail. For in that case would have this dot remove tail. And you can see over here we could say that it removes the tail, and the condition if it's not the head or the tail. So it should be somewhere in the middle, right? The node. So for that case we could have node next node. We're gonna have to try to find that next node by using node to remove, and we're gonna say dot get next node, and that's our next node. Similar to that, we could find our previous by using node prev node, and we could say node to remove, and we could say get prev. So get prev node. So we got the next and the prev node. Next node dot set previous node, and we're gonna set that to the prev node. And over here we have the prev node dot set next node, and we're gonna assign that to the next node. So we could exit out the whole mumbo jumbo here and return the node to remove because we had the return type of node. We forgot to add the print method, which displays the whole list to our console as well as return it. So we're gonna create a doubly linked list, and we're gonna say doubly linked list, and we can say new doubly linked list. So once we create an instance of our doubly linked list, we have to create some instances for our node as well. So we say node 1, and we'll equal it to new node, and we'll say we have to pass in some data, so I'll say data 1. Similar to that, we could have this and this, so I'm just going to create 3, and we're going to have 2, and we have 3. We could change this to data 2, and we could change this to data 3. Let's pass it inside of our doubly linked list using doubly linked list dot addToHead or addToTail. We could use addToHead, and we just need the data, so we can say number node 1, and we say dot to get the data. And for that we could actually have the operation duplicated here, but we change the node to node 2, and this could be node 3, but let's just add it to the tail. Let's say add to tail. So once we do that, let's print this doubly linked list. So we can say print what we created here, and there you go, run the code. After debugging and trying to find out that pesky logical error, I came here and found out that the addToTail method had something wrong here. So we have string data, we put in the new tail is equal to new node data that we just assign a node. Cool, we got the new tail. And then we want the current tail, and we assign it to this dot tail. Pretty cool over here. But if current tail not equal to null, meaning that there is something inside of that tail, right? Before we say that current tail dot set next node is equal to new tail, which we said we wanted to add a new tail. That's good. But when we say new tail dot set prev node, right? We got to have the prev node is equal to the current tail because we want that old tail to be second last, right? Second to last. To get that, we had to change this to prev node instead of next node. That was some fault I found out. Now if I go back here and see if this works, because we have data 1, data 2, and data 3, so that means data 2 will be the first one, data 1 will be the second, and then data 3 will be at the end. And then after that we say Java doubly linked list, and we get our head, data 2, data 1, data 3, and tail. Awesome, we had other methods, but we didn't test them out. Now it's up to you to test them out yourself. Go try to write all this code by following this entire video, and then if you find any problems, then let me know in the comments. Until then, peace out.